Repair attempt at 6531 North Regal Manor Drive. A few of the things that we're going to be doing is taking a couple tiles off here, checking dimensions, taking a look at our hip tiles and our assembly, what's currently going on here with our hips, as well as our valley over here. And those should give us a baseline with these two items on what we're looking at with the remaining perimeter of this area and the adjacent slopes and the other side of the roof. Now, what we're gonna be doing here is taking a couple tiles off. Nothing should be fastened in this area to the actual battens. Tools we'll be using are roofing hammers. Snake. Tape measure. Possibly a cat's paw if there's a fastener that we can't reach. Now, first thing we're going to do is lift up our tile a bit so that we can get these out. The purpose of lifting these up is so that the couple underneath just fall out. So should be able to access these pretty easy. So it looks like we are looking at a batten system with a 40-pound SBS granulated underlayment. As you can see here, we do have our granulated underlayment. We do have a batten system here. One thing I do want to notate is that we do have tie-in here from our flat to our slope. We do have a mandatory 18-inch tie-in. What we do have to do whenever tying in these perimeter slopes is we have to do that tie-in so that everything is lapping in succession to the slope. So when we start here with our first course, the next course needs to overlap the first course, and the third course needs to overlap the second course. And everything needs to lap in succession to the slope. And what a lot of people miss is where our battens are positioned in accordance with those laps. Now, put this down for a second. Come down here. Just gonna take a look at where our initial battens are. You're seeing all this debris because tile roofs are actually an open system. As long as you're not doing a direct-to-deck install, it's a lot more open on a batten system than a direct-to-deck. But the waterproof barrier is the underlayment. That's why we use a heavier, more durable underlayment. Our tiles act as UV protection, aesthetics, and a few other functions. But what happens is when we reach this point here where our battens intersect a lap, that lap always gets damaged. And looks like and right here is our main issue with this tie-in. Because once we reach this point with our tie-in, because yes, we have an 18-inch minimum where this material needs to underlap the material here. But as our slope laps in succession, when we reach this point here where we actually have our head lap on our underlayment, we have to maintain a minimum of a 2-inch lap. Now, this first course is going to be destroyed. But as we remove this first course, what's going to happen is this head lap here is going to get damaged as a result of removing the course directly below it. So what we'll need to do is continue up this slope until the ridge. Now, if this was just an up and over roof, we would reach a point at the ridge where we could essentially tie in. However, I'm going to leave this here for a second as we get into our area here. One thing that we do have to maintain is our laps based on code or manufacturer specifications. There was the TRI, which current manufacturers follow as their manufacturer standards for installation. But there is also code that states we have to make sure that we have a 2-inch head lap on our underlayment in succession to the slope. We also have to make sure our end laps, so this would be our head lap where this tile is overlapping this tile, and same with our underlayment. But our end laps are here, the vertical position on the slope. Now our end laps are supposed to be offset by 6 feet and overlapping a minimum of 6 inches. So as we start to work our way up this slope, we start to bleed into our hip. And our hip, as we will take a look in a second, as a standard is tied into the adjacent slope here. So we'll take a couple of tiles off here to display the underlayment crossing over into this slope, and then we'll see the same thing over here. And then we will move on to our valley. as you can see here, this is our underlayment continuing under a kicker ply. We have our kicker ply here. That is this piece that continues over our nailer board, our hip, ridge. If you do counter batten systems, sometimes you'll have your rake nailer boards, but in this case, because this is not a counter batten system, you won't run into those. However, I'm referring to this as our kicker ply. It continues up and over the nailer board and onto the next slope. However, what we are seeing here is our underlayment continuing from this slope here under our nailer board into this slope here. So as we deconstruct this slope, what's going to happen is we are going to bleed into this slope. Now, what that looks like, because of our end laps needing to be offset by 6 feet, our head laps needing to maintain a 2-inch minimum overlap, and our end laps needing to maintain a 6-inch overlap minimum. What we're going to run into is when we need to run our underlayment into the hip and into the next slope, we are going to need to offset our end laps by 6 feet. So if I have an end lap end here, my next end lap needs to end 6 feet from here. And this I can display with a tape measure. Essentially what's going to happen. An end lap ends here. That is 6 feet from here. And essentially what's going to happen is we're just going to bleed into the slope, end up damaging the underlayment that is currently here, and that's going to bleed into our next hip. And then we're going to have to offset our end laps again with our underlayment. We're going to run into the same issue here where we've got our base layer of underlayment continuing into the next slope, and then we have our kicker ply going over our nailer board, which is on top of our base layer of underlayment. And again, these are just industry standards. You either have a hip and ridge flashing that goes here, or you manufacture some sort of a kicker ply to encapsulate that nailer board and shed water from the hips and the ridges back onto the slope. Now, next, we should be done observing all of that information. One thing I do want to do is take the dimensions of these tiles. Resting on 17 inches. By 10 and 3/4. So 17 by 10 and 3/4. With both interlocking, we're looking at 12 1/4. And this is a life tile. Interlocking system is no longer manufactured. When I mention interlocking system, I'm talking about the system here on the side of the tiles that allows for watershed and wind resistance. And when you look here, we have our tiles that interlock, and essentially what happens is if I lift this tile here, it lifts that whole course. It doesn't take much But when those interlocking systems here do not match, the tiles will not shed water appropriately, and the wind resistance will not be maintained if those interlocking systems are not matched up, basically causing collision between the tiles. And anytime you have concrete smacking together, you're going to see breakage. Put these tiles back. Now on to our next issue. Okay, so we outlined everything here and how our hips tie in, how our underlayment, our base layer, and our kicker ply. What we're going to observe next is our valley, and then we'll move on to our ridge, and then go through a complete overview of the whole roof. Now, what I want to take off is a couple of these valley metals, or valley tiles, to display how this valley metal here is tied into our slope here and our slope here. Now, essentially what happens here, where we have our tie-in on our valley, is going to be our valley flashing, our metal flashing actually continuing under here, because we do have a lap, but we have our batten system that ties into our valley. So as we remove these battens and this underlayment, what we're going to see is another base underlayment under here, continuing under our valley metal. And I can't lift this too high because the underlayment's really brittle here. Always is at the valleys, but as we start to tear all of this out, what we're doing is we're damaging the base layer, which is the waterproof layer, which catches all the water from essentially here, this point, all the way up to our ridge. All of this water flows into our valley and then sheds into here and then out our scuppers over here. So if we leave this area damaged here at our valley, where all of this water collects, water can shed down this slope and over there nice and evenly, but what happens here in this area is you catch all of this water here and all of this water here flowing into this valley. And this is one of the most vulnerable areas in our roof. So when we remove these battens and our underlayment and anything penetrating these metals or the base layer, waterproof layer underneath the valley metal, we need to remove that valley metal. Now again, same assembly on the other side of the valley metal, we're going to end up damaging this. And again, with our offsets of our underlayment needing to be offset by 6 feet, needing to maintain a 6-inch headlap. Also, like we discussed over here with the flat roof needing to tie in a minimum of 18 inches, we're going to see issues here as well with our tie-in, that we're going to have to replace that first course of underlayment, just like we discussed over there. And it's going to bleed up this slope. It's going to bleed into that hip onto the adjacent slope over here. And then we have another valley assembly. We have our sidewall here with likely a J-pan, and it looks like we have a J-pan here. Gable corners return here. So as we bleed into this slope, we're going to bleed into another valley, bleed into another slope. We're going to have to maintain those end laps. And then we're going to bleed into this hip and in the next slope. And with this being a discontinued tile, with us, even with detach and reset, with us taking these tiles off, some of them get damaged every single time, and there has to be a sufficient replacement for that tile that can interlock with the remaining tiles. And because everything up here has been discontinued for such a long time, and no one manufactures that interlocking key on the side of the tiles anymore, or these dimensions for that matter, all of this is not repairable. So what we're looking at is needing to replace this slope, bleeding into our hip over here, bleeding into our hip over here, bleeding into this slope, as well as this slope bleeding into our valley here and our adjacent slope over here, and then that hip, another valley, another slope, another hip. And one last piece is our head wall flashing. Our sidewall flashings need to shed water back onto the roof surface. That is the purpose of our flashings. It's the purpose of step flashing with shingles. It's the purpose of J-pan, C-channel, channel metal, what everybody wants to call it, whatever you want to call it on a sidewall. We have our head wall flashing here, and it always needs to feed water back onto the main roof surface. And what we're gonna see here is our underlayment. Our underlayment is going to continue up and under this head wall flashing here, and we need to maintain that. Basically what's going to happen is we are going to see some stucco damage here, and we're going to have some flashings that need to be replaced. Same with our skylights. These are curb mounted skylights with, looks like, custom flashings. I believe we do have a channel metal here as well. That's everything for 6531. And now we're going to put all of our tiles back in place, collect our tools, and get out of here. I do want to mention that these older discolored tiles here look like they've been used for years, but they are a life tile. One of the issues we are going to run into also is trying to maintain any fasteners that came out and the penetrations that they go back into, but also the underlayment. What we're going to run into issues with it is it only retains its self-sealing abilities for anywhere from 5 to 7 years. A butyl-based underlayment maintains it for anywhere from 10 to 15 years. However, with this, there are going to be issues with making repairs and trying to get our fasteners back in the same penetration when you can't see underneath the tile. So I can see a little bit better. That's not gonna work. Let's see here. What do I have? Well, terrible balancing. Let's see. There it is. Poor snake. There we go. Now, like I said, the last thing I was going to document was the actual lap here at our ridge. As you can see, we do have our underlayment continuing under and a kicker ply here as well. We do have a sidewall flashing here that will likely need to be replaced so that we can continue our underlayment up and under over here on our sidewall, because our house wrap is supposed to continue down over our sidewall and our roof underlayment coming in, continuing up the sidewall. So basically our underlayment continues from the main roof substrate up this wall here, and then our channel metal, our sidewall flashing here, continues up the wall out here, and then it has a flange that continues up to catch water that gets underneath the tiles, and it channels it back off of the roof or back onto the roof. But we will run into stucco damages there and there. That wraps up this repair attempt for 6531